Hello, and welcome to a little video about Target 2A. This is where we made connection between arithmetic sequences and linear functions. First, we discussed the definition of average rate of change. The average rate of change is the distance between 2 points on a graph. So, let's take a look at this graph. This is a U-shaped graph, and we're going to find the distance, the average rate of change between -2, 1 and 0, -3. So rise is the movement up and down. So in this case, from the left point to the right point, we moved down 4. That's why our rise is -4. Then to get from our left point to our right point after going down 4, we move to the right 2, and that's our run. We can reduce that to -2 over 1. Reduce when possible. That's going to give you the best answer for your average rate of change. Let's calculate it on something that's not already worked out for us. For example, this graph. So here we have 2 points. Let's find the average rate of change between them. This is my leftmost point, and this is my rightmost. Let's see the pattern. Okay, from the left point, I need to go up. Let's see how many, 5, 6, 7 spaces. Since I'm going upwards, the 7 is positive. And then I have to move 1, 2 spaces to the right. That's our run. Let's try another one. Okay, so this is my leftmost point. This is my rightmost. Okay, my rise. Well, to go from my left point to the right point, it looks like I'm going downwards. And it's down 2, so it's going to be -2 for my rise. Then I move over 1, 2, 3, 4, 5, 6 spaces to the right. And I can reduce that to -1/3. Now, we won't always have a nice graph where we can actually count the average rate of change by looking at the rise and the run. Sometimes we're going to be given a set of coordinates or a table. For that, we have a formula. Here it is. Delta y over delta x, which really means the change in y's over the change in x's. That's where we find the difference we subtract between the second point and the first point. Let me show you an example of what that looks like. Here is a beautiful table. We have our x's, we have f of x, which is our y coordinate. I'm picking 2 points. It doesn't really matter which 2 points I pick, as long as they stick together. So x1, y1 should be together, and I could have made, let's see, just as an example, I could have made this guy x1, y1, and this one I could have made this x2, y2. As long as the 1s and 2s are together, you're good to go. All right, now what we're going to do is plug in all those values. Y2 is -6, so I'm going to write -6, minus y1 is -12. I'm going to put -12 in parentheses because I don't want 2 minuses in a row. x2 is 0, and x1 is -3. Let's simplify. -6 minus -12 is actually -6 plus 12. Remember, when you subtract a negative, it turns into addition. On the bottom, it becomes 0 plus 3. So we get 6 over 3, which we can reduce to 2 over 1. Now, yes, 2 over 1 does equal 2, but when we're looking at an average rate of change, I suggest leaving it as a fraction. That way, we know definitely that it's a rise over a run. We can see it. It's clear. I think it's a good thing to do. Now, let's connect last unit to this unit. And we're going to do that by taking arithmetic sequences and reshaping them into function notation. And then we'll use that average rate of change. We will in a lesson a little later. But we need to learn these first couple of things, and then we'll connect it together. Right. So a tree is currently 10 feet tall and grows 2 feet per year. Let's model this scenario using an arithmetic sequence. All right, so we have our explicit formula right there. A1 is our first term, so that's what our tree starts at. And our tree starts at 10 feet. D is our common difference, so that's our pattern, 2 feet per year. Success. Next, let's rewrite it as in function notation, so as a function. The first thing that I'm doing is I am taking this formula and I'm rewriting it using function notation, so f of x, and I'm plugging in x's instead of n's. After this, we're going to simplify it. Okay, now, let's get rid of those parentheses. Let's combine some like terms. So in order to get rid of those parentheses, we're going to distribute that 2. And we're going to do that through multiplication. So our 10 stays as 10 because nothing happened to it. 2 times x becomes 2x. 2 times negative 1 becomes negative 2. Now, there's that bell. Okay, now let's combine some like terms. First, I'm looking at the 2x. Unfortunately, there's nothing I can combine that 2x with, so poor 2x, lonely 2x is all by itself. Next, I'm going to take a look at that 10 and 2. They happen to be like terms. They don't have any x's, they don't have anything. They're just plain old constants, regular numbers. So let's combine them. 10 minus 2 is positive 8. So our function notation becomes f of x equals 2x plus 8. Letter C asks us, how tall will this tree be in 5 years? In order to do that, we're going to take 5 and plug it in wherever we see the x in our function notation. So 5, 5. All right, let's simplify. 2 times 5 is 10 plus 8, which gives us 18. So 18 feet. All right. If you have any other questions, please feel free to reach out to me or to your teacher and let us know. Otherwise, have a wonderful rest of your day. Bye.